Alright, frame relay in GNS3. Let's get started here. Just throw 3 routers out here. Let me just rename these. And we need to add some serial ports. Going to configure, select the router, slots, down under WICs or WAN interface cards, 1T or 2T. We'll just go ahead and select 2T. Probably going to use 1 for this lab, but just for the heck of it. Router, slots, WIC, 2T. Alright, and then you want to pick the frame relay switch, which is more or less a dummy device, meaning that it has no CLI. You're just going to configure everything from here. So basically this is where you set up your DELCs. DELC is an acronym, stands for Data Link Connection Identifier. It's a type of layer 2 connection. I would compare it to MAC addressing, similar but different. So the way that the configuration works is we're going to use port 1. We'll define this as well, let me start off by saying that by configuring DELCs, basically what you're configuring is a PVC, or a permanent virtual circuit as they refer to it in frame relay world. So we'll create a permanent virtual circuit, PVC if you will, from router 1 to router 2. And these numbers, as far as the DELCs, you can choose whatever you want, but it is helpful to choose numbers that make sense. And by that I mean, we'll say port 1 is going to be the physical port that's going to connect to router 1. So we'll call this DELC 102. And by saying that it makes sense to use 102, what I mean is it's going from router 1 to router 2. So when we come back, it'll go from router 2 to router 1. Therefore, we will name this DELC 201. And we'll put that on port 2. And once we connect the, I was pointing at router 3, but I meant to point up here. Once we connect the routers to the frame relay switch itself, you'll see what I mean. It makes a little more sense. So let's go ahead and add this. We have our first DELC set up, 2 DELCs, first PVC. And for our second one, let's go for 103. I'm sorry, this is going to be port 1 again, because it's going to go to router 1. 103, and this will be port 3 is already correct, and we will do 301. Add. So we have our second DELC. And that gives us connectivity from router 1 to router 2, and then from router 1 to router 3. Now if you want to make another one, you could do a DELC from, let's say, router 3 to router 2, but we won't go that far into this lab. It's pretty much the same exact thing. You would just make another DELC, but we're just going to connect these, and then we'll test connection with them. So let's go ahead and apply. Okay. Alright, let's connect these guys. I'm going to connect them to the serial interface. And router 1, we're going to connect that to port 1, because that's how we configured our DELCs. Router 2, we will connect that to port 2. And you see you get this lightning bolt looking connection. That means it is a serial or WAN. Basically means it's a serial. I shouldn't say WAN in this case. So let's go from 3 to 3. Now let's fire these guys up. CPU is probably spiking right about now. Oh yeah. So we need to open up a console to all these, or else it's just sitting there waiting. Boom, boom, boom. CPU drops. Let's jump over to router 1, go into global config, and we will hop on interface serial 0/0. And to set this guy up for frame relay, it's very straightforward because we're just doing a basic frame relay config. Encapsulation, frame relay. Ta-da! Okay, then you want to follow that by a no shut. And let's go ahead and throw an IP on this guy so we can confirm. Router 1, we'll call it 1.1. And we will put all 3 of these routers in different subnets on purpose, just so we can show that we can communicate. It might help if I add the right command here. IP address 10.10.1.1, 24-bit mask, a little no shutty. Alright, let's hop over to router 2 and do the same process. Conf2, interface serial 0/0. Let's do a cap frame. Let's do IP 10.10.router 2.2. Try again. 24-bit mask. Let's do a no shutty. Alright, let's hop over to router 3. Get into global config mode here. Okay, interface serial 0/0. And let's do a little encapsulation. Frame relay. IP address 10.10.router3.3. Haha, twice in a row. 24-bit mask. Without the letter. No shutty. So, could have just did Control Z there, but anyway, let's do show. I think it's show frame relay, private virtual connections. So we see that we do have one. That is Delcy 301. Interface serial 0/0. Let's also check, what's another one? Show frame relay, not PVC. Let's take a look here. Relay, frame relay map. That's not the one I was looking for. LMI. Once we get some traffic going, we'll see counters and things like that, but it does show you that frame relay is set up. This is the DTE, meaning the router. DCE would be your clocking device, which is usually always going to be your frame relay switch, not yours. It's going to be at the service provider or the frame relay provider, I should say, on their end. LMI type ANSI, we won't get into any of that right now. Let's just go ahead and verify connectivity. Ping 10.10.router 1.1. Alright. So, I wonder if we do that now. No, we still don't have any traffic there. That's okay. I'm not going to get into that. Let's go ahead and ping 10, Control Z, 10.10.1.1. So on router 1, I just want to show you if we do a show frame relay PVC, we should have 2 permanent virtual circuits. So we have 102 and we do have excuse me, 103. So we have 2 for this one because we remember the delcies we created are we have 102 and 101. Both of those go to port 1. So we have 2 PVCs for router 1 and only 1 for router 2 and router 3. So let's just verify. Ping 10.10.router2.2. Ping 10.10. Excuse me, router 3.3. And show frame relay map. Now, I guess you have to generate traffic first just to confirm. But now we have a map. It shows us by going through delc 102, we can get to 10.10.2.2. So if we do the same thing here, yeah, after you generate traffic, then your map is built. That's what it is. Because it uses the inverse ARP. And I'm just curious, since we've pinged over here now, we should have some traffic. Show frame relay LMI. Sent 22, receive 23. Those are just updates. Okay. If we do a debug frame relay packets, we do see the traffic's coming through, so I'm not super well versed on the inner workings of frame relay as of right now, but I don't know exactly what those counters are showing, but you would think since the traffic is definitely getting there and it's recognized through the debug command that we would show some traffic within the show frame relay LMI. You know what? That's something completely different. I'm sorry. Alrighty. So at least you get the gist of how to set up frame relay on GNS3. Very simple. And I plan on making a more advanced, perhaps frame relay troubleshooting video soon. Thanks for watching.